Okay, so um, we're going to now build on the work that we did yesterday, and by extension, on the specific neighborhood mobility model that we constructed in the final hour of the bootcamp session yesterday. Um, Within this context, we had people situated in one of three resources: home, work, or school, and were circulated between them. Those resources were placed within a spatial context, and that spatial context mediated certain aspects of the model. Most notably, uh, individuals who were children within this context were associated with schools, which were the nearest school to, by extension, their home, since this is reached when they enter from their home. And this notion of distance, as I had noted to Roselle yesterday, was one that was dictated here by Euclidean distance, the kind of straight line distance, crow flies distance, as it were, of a school to a home. But in general, could be we could use other metrics of distance were this a GIS model, which is one of the choices we'll have if we want to spend time with GIS models this afternoon and early tomorrow. We could. But something that's more notable than sort of that binding of an individual student to a school is the fact that they circulate, and the adults circulate between their home environment and those corresponding daily environments. For adults, it's a workplace, shown in this sort of factory color. And there's a movement back and forth at the end of there's a daily cycle here of 24 hours. At the end of 16 hours at home, they either move to school or they move to a workplace. They spend 8 hours there and then they move home. Now, there's a set of things that I glossed over to build this in an hour and put it into the broader context with populations of agents, to implement it through populations of agents, and where the people have an associated random home given to them, a random age, and a random workplace, but where there are these mobility patterns induced. We had to cut some corners for that to be fit into an hour. And I did want to flesh out a little bit a couple of features of that just to make some points. So one of the questions which was asked early in this boot camp concerned the scale of this space. So we have this kind of space where things are laid out, but it wasn't maybe clear what the scale is. And at that time, and I'll, at the cost of repeating myself, I'll emphasize it now. There's a scale of distances that any logic uses for those layouts. Now, this shouldn't take away from the fact that in many cases it's useful to have a rather stylized depiction of space. We're really more interested in some cases in places that people circulate, and it's not as material where those happen to be geographically or even geometrically located relative to one another. There are cases where that's a second order issue, and really we're interested in the topology, what's connected with what as a space. And indeed in mathematics, there's this whole area of topology which deals with very general notions of places, as it were. So I don't want to suggest that every time you have an abstract model of space, you need some geometry, you need some very well-defined distance metric. But there are times where we do want this, geographically, certainly, and sometimes here. And I do want to say that to the degree we want to make use of that sort of metric, and to the degree we care about speed of individuals, like that persons move at a certain rate across this space from one place to another, to the degree we care about, the truck holding the heifers moves from the cow-calf operation to the feedlot at a certain rate, because it mediates the spread of infection in the truck or whatever. To the degree that is a concern, you should be aware that there are these affordances offered to take this into account. And I'd like to sort of futz with this a bit to make some points. So we just ran the model and we saw its kind of depiction of the placement of these resources. And, we were approaching it, I think rightly so, here as a set of abstract spaces, places. And there was some effective geometry, like kids go to the nearby school, but it's kind of in the background what the distances are. I'd like to see how we could approach it a little bit more specifically with like rates of travel and actual distances of some sort. So to do this, I'd like to go up to this thing here, this 10 meter, and I'd actually like to set it so that this distance corresponds to, I'm thinking of a small town or something. Maybe this corresponds to 50 meters or something of distance. And we're dealing with a space that has, so this area measured is, let's say, 50 meters, okay? And I'd like you to, and I'm going to save this as a new version just so we're clear. We have successive versions we can go back to with or without this. And I'd like to look here for what's induced, like what's the result of that change, of imposing this larger scale for this space. Well, you'll see something that maybe will surprise you a little bit. Maybe you'll say, well, what are those red and blue and yellow dots? Well, those are the same things those were there before. They're recognizable, but they're spread out over a larger spatial area. If we wish to think of it as in terms of a real space, certainly as a metric of some sort on it, but a physical space. And I want to highlight here that, thank you, Jeff. Yeah. That what's happened is that these little icons, these little resources themselves have a certain size in meters associated with them. And previously, when that little yardstick thing, the meter stick, when that was 10 meters, these were a lot bigger visually because, maybe this is 10 meters across or 5, something like that as a workplace, and 10 meters the other way. And so it took up a bigger visual area of it, right? The footprint visually was much larger. Same thing with the house. Same thing with the person. But now if we have that little ruler thing be 50 meters, these things look at first glance at the same measure of scale, at 100% scale, they look puny, they look tiny, right? Because their relative, their visual size reflects the size of that resource within this broader space. Now, this may get your mind racing. Like, okay, so So now we have like they're distributed around there on the scale of like this distance over here might be getting to be half a kilometer, maybe a little bit more, diagonally or what have you. Think of this as a small village or something, small town. So now if we have people moving in the space, their speed has some bearing on like how long it takes them to get to their destination, right? So if we go to person here and we see their initial speed is 10 meters a second, well, they ain't walking at 10 meters a second. Average walking speed might be somewhere between, maybe around 1.5 meters a second, somewhere between 1 and 1.5. Obviously, it would be slower for kids and stuff, although kids can exhibit, surprising acceleration. And we could put in a speed for the person class for things in the person class. If we don't override, if we don't set it explicitly, like this person's in a wheelchair, so they move more slowly. This person is a toddler, so they go more slowly. This person is with a cane, they go slow. We can do that on a per person basis, per agent basis, set their velocity. Here, we're doing it for all agents in the class. And then you may ask, well, where does that have impact? Well, it has an impact when they move to a resource. This is not an instantaneous thing. If we want it to be instantaneous, we would say jump to, and they would, Scotty would beam them up on the teleporter, like they teleport over, right? Boop, they'd appear over there. But this move to is actually moving them at that speed to that destination. And they will go with that deliberate speed to their destination. So let's go in and check this out, if we may. Maybe to further the point, I'm just gonna do something absurd in terms of physical. Instead of making it 0.15, 1.5. For the moment, I'll make it 0.15. So they will go really slow. Maybe it's a baby crawling or something, right? Really, really slow here. And just so we can see their transit more obvious. We would have been able to see a little bit. We'll come back to that, but let's just see their transit at this sort of broader scale where, the community might be, half a kilometer across or something. Okay, I should have zoomed in here. Okay, here we go. Coming up on 14 hours. And they moved. Okay. They still move pretty quick, I've got to say. But we can see them kind of in transit fleetingly, I would say. They're moving, they're in their overnight slumber here. But they'll move to their workplace. Let's go see. I think what we'll do is to sort of make this point a little bit more clear. I'm going to stop the model. I'm going to run it until a certain time. I'm going to run it till, I happen to know you may remember, they leave after 14 hours. Or sorry, 16 hours. What am I saying? I'm going to run it for 15.5 hours. Run until that time. Here it goes, and I'm going to leave it on one speed because I don't want to. I'm going to switch it with this little home thing so I can see this. Okay, it's time 15.5 hours. They've woken up from their slumber, and And now they're ready for their day. Here are some kids that will end up presenting at this school. Hmm? Now let's go. I'm going to slow it down a wee bit. I'm going to slow it to like, say, half speed. Okay, fine. Here we go. And maybe a fifth speed. There we go. Okay. And now I'm going to run, and we'll see it'll come up, and then we'll see, oh, there they go, right? They headed to school. And now they're in school for 8 hours. Um, and so it's the time ticks up here at time 24. They will return home. And we'll see them once again, in transit to home. And there they are, returning to their homes. So you could see there's actually mobility going on. There's movement across the space going on that is itself taking some time. I mean, it takes some time to traverse it. And quite often, not always, but quite often, we will want to take that into account in some sort. If this was the pre-pandemic era and you lived in Orange County near LA, where I did some of my first health policy modeling, people would get on the highway sometimes at 5:30 in the morning so that they could get to work before, within an hour and a half or whatever. There were, in some cases, 2-hour commutes or something undertaken. And so if you're concerned about, characterizing those sort of effects or infection transmission in a taxi that takes someone from La Loche down to Prince Albert 3 times a week, as we were during my secondment, we worked on that. Wade's familiar with that project, and taking people to dialysis appointments, and there was concern for these very immunocompromised people. The risk that someone with end-stage renal disease could be infected by COVID by a taxi driver or one of the other passengers was very material. So if we want to capture something like that, what we could do is put in mechanisms for in-transit time periods within the model. So to that end, I'm going to take this model and we're going to modify it a little bit. And we're going to introduce an important extra primitive. It's really important when you're dealing with mobility to know about it in any logic. I'm not necessarily doing this because it's going to be super important for our particular domain context. That's very arguable. But it is going to be important as a learning tool for dealing with mobility and GIS and more abstract models to characterize these things. So what I'm going to do is I think I will distribute the model that I currently have to people, and then I'm going to so this is the model built in class, and you'll find it at, here we go, version 5 of the ABM neighborhood mobility model is posted. Yes, thank you, Jeff. That's great. Yeah. Okay, so I posted it there, and is it? Yes, it's there. Yep. Okay. So I posted version 5. I'm going to save this as version 6. What I'm going to do from now on will be subsumed under version 6 until my next post. Okay, so what's next is we are going to put in place some in-transit states that are going to mark them while they're moving. Before we do that, we're going to put back person's speed of mobility to 1.5 meters per second. Okay. Maybe we'll make it to reflect kids 1.25. The might bike or I don't know. Do they still have big wheels? Like maybe some big wheels to school. Anyway. Okay. So here we go. So we're going to give ourselves more space, and we're going to put in from the palette here some more states. Okay. And there's going to be, for each of these states, a corresponding state that's in transit to. So if it's at X, they'll be in transit to work. In transit to school. Hey, come on. And then we're going to sort of consolidate our state chart for a single in transit to home. To home. And I think what we'll do is, rather than breaking the symmetry by putting it over, well, over A on the left or right, we'll put it down here for now. We'll be elaborating some other aspects coming up, but these folks, instead of going up here, will now, when they leave school, they'll be in transit to home. This connection will go to in transit to work. This one will go to in transit to school. And then, and this is rather significant, we're going to have arrive school. Arrive at school? Yeah. Okay. And this is a trigger, a new type of trigger. We've used timeout, we've used rate, we've used message. Now we're introducing an agent arrival trigger. Okay. This is going to be an agent arrival trigger. Okay. And this one will be arrive at work. Oh, make sure it's shown the name. It's important that models be transparent and make sure these names are shown. Wade, I noticed that arrival transitions now have a timeout associated with them. Oh, well, wait a minute. It's just no, it doesn't. Okay, could someone take that down as a bug in the AnyLogic interface? When you switch it from a timeout transition to an agent arrival transition, it actually doesn't properly update that, so it looks like it has a timeout associated with it. And now we'll have to get them back to home, and this is where we'll have to break the symmetry. I'm gonna click over like that. So now they're going home. Get back here. Oh, come on. Well, what it lacks in beauty, it's going to make up for in utility. Okay. Okay. This one, wait, check this out. So this is going to be arrive at home. Watch this, Wade. You see that?
Yeah, I see that.
It's 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 rather florid. Um, it's like a florid delusion. It's keeping this. And then if you switch away from it and you come back to it, it's gone. um, so anyway, um, yeah. Okay. Um, okay. Great. So we now have these arrival transitions, and I want to highlight that that arrival will take place when they indeed arrive at their destination. Thank you, Jeff. Thank you. Um, that's good. I'm glad they fixed that bug. Thanks. So we don't have to report it. Okay. So if they head off here, we'll put them immediately. Remember, transitions are just they occur like the once a transition is firing, you don't spend time in the transition. Just like in system dynamics modeling, if you have a flow between a susceptible and effective, you don't spend time, inside the flow or something. You're not in there for a certain period of time, like going down the pipe or something. No, this is just like you once it fires, you enter the state. So this action will be undertaken, move to school, and they will go here and they will be in this movement state, moving in space, just like we saw, moving around, and then they'll arrive. And it's at that point of arrival at their destination that they will go to at school. Same thing here. They'll be heading to work. While they're heading to work, while they're still heading to work, they'll be in this state. And then they'll arrive at work and they'll get into the at work state. So it's not counting them. Previously, it was counting them at being at work or being at school, even while they were transitioning, while they were moving across the space, while they were commuting. And similarly, it was counting them to be at home while they were still moving. Maybe in this model, it won't make a huge difference, but in general, well, for some cases it does, particularly like the medical taxi example I gave you, or if you're trying to understand certain types of impacts on a person's quality of life, of their commute or what have you. Yeah, or if you're dealing like in some modeling we did for our Ministry of Justice, Ministry of Corrections and Policing, like for court documents, will take time to drive down drive across the province, and a court proceeding may be delayed because those documents haven't arrived yet, or an RCMP officer may need to present, who's stationed down in Maple Creek, may need to present for a deposition in Saskatoon, and it's going to take them 4 hours or 5 hours to drive. And so, this issue of kind of in transit and arrival is sometimes actually rather significant. Okay, so let's let's run the model. Let's make sure it builds. Let's make sure it runs. This was should be largely invisible here. For these changes. It's simply that they will be in that state. And we could color them if they're in transit, but I don't think, in the interest of time, I'm not going to do that. I did want to highlight the importance of the agent arrival. That's a type of transition rule that it takes out explicitly mobility. That's what its job is, to handle mobility. And it's very useful. Okay, so this was our little mobility model. And we're in, we have a little nice consistent model, but I want to elaborate it with one more thing. But before I do that, I want to distribute this model to you, because maybe some people had to leave during it, or otherwise might have gotten stuck. And so here's my version. I've just posted it, and I'll now start in version 7. Okay. So what we're going to do is add a set of community places, set of locations in the community. Okay. So right now we have a set of resources, homes. We have persons. So homes are with a kind of homey icon. Persons are with a anthropomorphic icon. Schools are with a one-room schoolhouse-like icon. Yes. Workplaces are with a factory icon. So we're now going to add another type, which would be called community resource, or community space. It's going to be represent diverse types of community places. And giving this an icon is going to be hard, because those community places could be places to gyms and places to work out. They could be stores. They could be, so grocery stores or consumer shopping outlets of various sorts. They could be, religious facilities or community gathering places, community centers, etc. We're going to give this a rather generic name, but please be aware, like, if you wanted to examine the impact of certain types of public health orders on certain types of gatherings, you could break out, a type of resource for that type of community gathering. So maybe, types of large music festivals. We've done place-based, like gathering-based modeling before during my secondment with Wade and others, in simulating the effects of infection spread at community venues. This is not to suggest all community places have to be glommed into one, but we're going to continue on the simple stylized form of this model. Okay, so I think we'll put we'll make it a kind of a black box. We'll make it a box. Well, it's not black, it's brown, but it'll do. It's better than a fighter jet, better than a ship or a forklift or a lorry, or a cloud. Okay. Okay, so this is our community place. Great. So we're going to now, having added that type of agent, I did, again, new, sorry if I typed that too quick. So I did a new agent type community place, right? That's what I did. And I created that. And then having gone there, I opened it up and I went to palette to this one down here, pictures, and I dragged the box in. I'm sorry for not having been suitably explicit with that. Appropriately explicit. Properly explicit. Okay, so here's our community places, and we're going to add a population of these places. Where does that population live in the model? You tell me. Where do populations live in this model? They live in give you a hint. Augusta, Brunswick, Kennebunkport, Portland, Boothbay Harbor. Those are all in what? On Hagen Island. They're all in Maine. Except this is the type without an E. Okay. That may have been lost on people. Okay. Maine, folks. Maine. Let's go to Maine. The community places, the population of community places live in Maine. These will be called community places. You live in Maine. What do I need to do? What do I need to do to make this a population? Is this a population now? The answer is no, it's not yet a population. I have to make it a population here. Good, good. Population of agents on top. That's right. Excellent. Yeah. And what will, oh, that's interesting. Hey, Wade, check this out. Do you see, Wade? There's no like.
Oh, I see that.
What's that?
I see. What happens if you switch back to single agent and back to population?
That's same thing. Let's
See,
go.
I'm not getting that
Yeah, you may
on
have
mine.
a somewhat. Okay, now I switch away from it and I have it. Okay. Yeah, it's not. It's exhibiting. This is also the Linux version, and I'm not awfully happy with their attitude towards us Linux users. Okay. Initial number of agents. We'll make this. Yeah, testing on a Linux, and there was an issue. Yeah, it exhibits this function. Sometimes I mean it's imperfect. I'd say it's not terrible, but it's enough to be kind of disappointing. Okay, so it's going to be the initial population size divided by. We'll make it 20. One community place for every 20 people. This is an integer division. We're not going to keep track. It's not a partial community place park that's really small park or something. Initial population size divided by 20. Okay. And those two, because we have in main that all of the things within it are randomly placed, those are going to be randomly placed. Now, again, any of these, if we wanted to arrange these all in, or any of these in specific locations, we could always use this initial location to set them, to set those locations. We can even read it out from a database or something. But for now, we'll just live with this. Okay, so now we've got this space and we're still at a rather broad level and we've got big box stores there. Okay. There we go. But right now, they are not included in people's daily itineraries. So what we want to do is provide a way for them to go and potentially visit places in the community. Okay. So we'll say after school or work, they can either go and transit to home or visit places in their community.
Sorry, just want to confirm, in our initial conditions, they will be randomly distributed across all sites?
Yeah, that's because right now, great question. Right now, we've elected not, for the purposes of keeping this example a little bit smaller, we've elected not to impose any sort of custom location distribution on, for example, the schools or the workplaces or the community places. People will be placed with their homes, but we could impose on these as a population a certain initial location. So we could make, schools or workplaces predominantly be in some area of town, or for zoning reasons, have them separated from the schools area or what have you. But instead, we took a broad brush and we just said, okay, look, in Maine, we're going to delegate that to Maine layout. If we did, otherwise we could say like user defined, in which case then we could go specify these. And I think even if you say random here, Wade, could you double check my impression of this? Challenge it, please. If you say random, but then you say one of these populations is at some location set through some custom rule, like drawing it from a certain distribution or drawing it from a database or whatever, I think that will override the random one. It will randomize other things, but not the population where you've provided explicit rules. That's my recollection, Wade, but could you check that?
Yeah, I'll check that right now.
Okay, thanks. Yeah. So here, Sarah, to answer your question, yes, right now their locations are being set by virtue of this being random.
Oh, thank you.
Hey, it seems in the current version of AnyLogic 895, it won't allow you to set like if your school is in Maine, which has a random layout, it won't allow you to set at the school level.
At the population level, I mean,
At the population level, I should say.
it won't allow you to set the initial location.
Yeah, so like, see, that's all it says if you look at the chat.
Um, Determined by the random layout. I see. Okay. Okay. So it's trying to avoid people being potentially confused. Like, wait a minute, I have the initial. Well, yeah, I don't know. You might be confused by saying I'm saying it's random, but it's still putting them at certain locations, even though they did that. Okay. So if you
I think if you wanted to do that,
you have
well,
to
you
do
don't want to take them out of the space though, eh?
no, you could say user defined, but then you'd have to do it for all the populations, right? Like give a you
Yeah.
it's not a hard thing. I mean, honestly, that random thing is just a it saves less than 5 minutes because if you were to go to each of these populations, if I said I wanted homes, if I didn't have that affordance of a random layout, then I could go to each of these populations except people, because people are bound to their homes. But I could go to these others and I could say, place it at a specified point, and then I could. Okay, I'm going to close my any logic and reopen it. See, Wade, it doesn't indicate.
Yeah,
That.
I
Yeah,
see that.
I'm gonna I'm gonna close this and I'm gonna reopen it because it's exhibiting truculent. By the way, note this, Wade.
Oh yeah.
Um, okay. Um, so yeah. Coming back to this, if we did homes here, oh, sorry, homes here. Um, if I said in the specified point, it would allow me to say like uniform between 0 and space width. That's all random does. Is it does this for X and this for Y. Come on, come on. Well, fine. I have to modify it anyway. Uniform 0.0, comma space height, like that. That's what saying random does for the whole space. And if I went and I copied this to each of these other populations besides persons, besides populate, this one called population, and did the same for this, then I'd get the same effect. It's just, it can save about 5 minutes or something. No. So I'm going to get this out of here just to avoid. Oh, look at that. Okay. 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 So just coming back to our point, we're going to need to modify this to go to a random community place. We basically are going to have to decide, are they going to go home directly or are they going to go to a community place and then go home? And to do this, I would like to add a little bit of, I'm going to add one parameter to main. So, by the way, this is, if you minimize these things, some things can be minimized here. And like the properties window is minimized right now. I think it may be because I zoomed in on this. I double clicked on this and it zooms in. If I double click out, so this lets me just focus on this. Double clicking out or double clicking will kind of zoom out and allow me to see things. So what I want to do is I want to go to main here and I want to add a parameter to main that's called probability, uh, probability or prob, visit, daily community place visit. It's not the best name, but it's not the worst name. Okay. It's better than A or something. And I'm going to make it initially 0.5. No, I'll make it initially 1 to say, okay, they visit community places regularly after work or home. Okay. So we're going to have them potentially go to a community place. And whether they go there is going to be determined by branch. That's how we decide whether something happens or not. So both of these are going to go to this decision point, this branch. You see in flowcharts. Hey, come on. And one possibility is they directly go home. Hey, I'm going to just try to move this around. The other possibility is they go, you're going to add a state, actually 2 states, in transit to community place. You could see this kind of cruffs up the model, or it makes the model a little bit, it kind of puffs up the chart, the state chart, in ways that aren't that that are a little bit distracting, but sometimes to good purpose, and I'm using it to teach the lesson of arrival. And then we're going to have one that's going to be visit community place. Visit community place. And we could have them like go from one community place to another, in which case they'd kind of loop back and forth, boop, 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 a couple times if we wanted, and then go home. But for now, we'll just have them go to 1. Here we go. And what sort of transition will this be from in transit to visit community place? What sort of transition will that be? What sort of transition completes a transit and marks someone as having arrived at a community place?
I was going to say, but you answered.
Okay, arrival. Yeah, agent arrival. Yeah. So this is going to be arrive at community place. And once again, I've realized I have fallen short of my admonitions to students. You should be showing, oh my gosh. Oh my gosh. I'm hung again. Okay. So this is going to be deciding post-school activity. Okay. And show. And this will be deciding post-work activity. There we go. And then from this, they will either go this way, or they will bite, or they will go this way. The default will be go home. So decided to go home. This one will be conditional. This will be decided to visit community place. Okay. And And then this will be after they visit a community place, after some period of time, they will go home. Okay, now, there's an interesting inconsistency which is creeping in here that we're going to have to deal with, and it's going to highlight for us a better way to undertake this. And I may need some help from Wade for some aspects of this. I'm going to say they spend going I'm going to call this going home after community circulation. And I'm going to have them visit the community for an hour. 1 hour. Okay, so on the face of it, that looks reasonable, and we have to finish the thought, but there's a latent problem that is hidden here. Yeah, okay, so one thing is like maybe they should be able to go from home to community. There are these things called weekends. Although sometimes I fear how long they'll last in the US. And then and so that's an issue. That's an issue of kind of model design, sort of model scope. And that's a very good point. Like maybe we should have people being able to visit community places from home. And that will further the other point. But let's finish the thought here. So when they go to a community place, they're going to need to move to somewhere. And we're going to need to move them when they start down this road in transit to community place. You'll notice here, like they move to their school. Here, they move to their workplace. When they go here, by all rights, so here, they should not move to home. That should be, and they shouldn't move to home here. So I'm eliminating the move to home from here and from here. And instead, the move to home should occur for both of these transitions. Now, when it applies to both incoming transitions, I've noted before that I would like to put it in one place to rule them all, which is the entry action of the state. So whenever they enter here, I'm going to go. And that breaks the symmetry. Like here, they're doing it right here. And maybe by the same, to be consistent, I'm going to move this to this entry point. And I'm going to move this to this entry point. Sorry, I just want to be consistent and not throw people off. Here, there's nothing that's going to go. Here, they're going to go to the state. This will go to the state. They're going to move to home here. And then my question is, where should they move here? To where should they move? What should the destination be for them here? Well, they should go to the community place. Okay, now we'll show how to do it right now, but we're going to need to modify this later for a certain reason. We won't. That's a little bit outside of our scope at the moment for this version of the model. But we're going to need to come back to it, and we're going to need to do it much as we assigned a school here. There's a reason we did that. and there'll be a reason we're going to have to modify this later. I'll show you a slightly more elegant way if you didn't have to worry about that. This will be moved to, where are the list of community places? Where's the collection of community places? Where does it live in the model? It lives in the place where Augusta and Kennebunkport and Monhegan Island and Booth Bay Harbor and Portland and Brunswick. Indeed, Bowdoin College. Where do those live? Those live in Maine. Okay. Probably lost to my Canadian students, but Maine dot community places. No, community. It should be called community places. Is it called community? Oh my gosh. It's called community place right now. That cannot stand. This is called community. It should be called community places. That's the type of name up with which I will not put. Students take note. There should be community places by all rights. Okay. So this will be moved to community places. Dot random. We're going to take a random one from there. And if you do dot, it should fill it out. Dot random. Give me a random one, meaning with equal probability. Okay, so Jeff, I did a quick succession of changes here. And people should note it, and I'm going to, because I don't see it in the chat, I'm going to go through them again, and then I'm going to post it. So the quick succession I did is I cleaned this up. This used to say go home. This used to say go home. And I consolidated that in this entry action because I didn't want to put it on these two transitions. So when they enter here, they'll start going home. And as long as they are going home, they'll stay there. But when they arrive, they'll head up on this transition because it's an agent arrival transition. That's one thing. But by the same token, and to be consistent, I took the code that was used to be up here, so like head to work, and the code here that used to be get my closest school and head there. And I put each of them in the entry transitions here. And then I put here a move to a random community place. Now, note that this is different. Like my nearest school is going to bring me to the same school presumably every time. My home is going to stay the same for each person. My workplace is given to me as a parameter. So all those, I'm going back to the same workplace, going back to the same school, coming home to the same home every day. But here I'm going to a different community place every day. And again, you could criticize it. You could say, well, they go to the same yoga studio every day, or they go to, the same grocery store typically. And fair enough, you could disaggregate. Some are presumably somewhat random, and some are regular, daily activities. And that could be broken out in a more detailed model. So I'm going to build this. I did those in quick succession, including this community places random. And I don't know that that's been posted. So I'm going to post it. Oh, no, that's not Ain. It's Maine. Sorry. Somehow it got truncated. Don't take that seriously yet. It's this. Oh, yeah, there. Hey, what? Why should have updated that. I said edit and save, but it didn't update. Let's get rid of this out of black spot. Okay. So I'm going to post this. So now they're going to random community places, and I will post this as version 7 coming shortly to a folder near you. Hey, no, not version 6. Sorry. No. Models. Yeah. Version 7. No. Huh? Okay, so something is kind of screwy. Okay. So we are on version 8 now. If I want to upload version 7. It's exhibiting this. So for some reason, it's not allowing me to upload that, and I'm puzzled why, but I'll see if it can upload version 9. I generally don't like to have it open when I upload it, just in case it's partway through being written or something. But here, I'm gonna upload version 8, and it's a happy camper with that. Okay, so it's up there, version 8. I skipped 7, but okay. Okay. But I puzzled you with, I riddled you with a challenge of thinking what the problem is here. What is the issue with this, with this model? And it might actually be such that it ends up being pretty obvious if I speed this up a bit and I zoom in. Okay, so
We're not seeing your model.
thank you. Yes, thank you for pointing that out, and please continue to object assiduously when I fail to properly respect my students. Okay, so this is a good example of where there's an inconsistency. Can you see a hidden inconsistency of what's depicted here that suggests the model is no longer capturing properly a 24-hour cycle? I'll tell you, people are desynchronized, are not being properly synchronized. Can you see this? Well, look, you've got some people at work, but you have other people at home. Some people at work, other people at home. In short, you have different people on different schedules. Yeah, people are spending 16 hours at home, regardless of 1-hour community visit or not. So the fact that we're sort of flipping randomly. Oh, wait a minute. Did we even have that random coin flip for that? Did I not put that in play? Oh, this is always true. Yeah, this shouldn't have been true. Yes, right now they're always going to the community place, which means they're in a 25-hour cycle. 16 hours plus 8 hours plus 1 hour in the community. But we actually want this at random true. We want to go this way based on a coin flip. And we want to do it random true dot main dot prob daily community places visit. Does this need a semicolon? No, because it's a negatory, because we're just determining a value, a true false value. We're flipping a coin and asking is it true or false, and that will be the condition. We're specifying a predicate rule that determines true or false. And it's calculating a value. like a formula. It doesn't need a semicolon. Semicolon is when you're doing something. You say, do it, change that, update that, make that happen, make that change. That's when you need a semicolon. Okay. Anyway, I'm gonna save that as version 9, and I'm gonna distribute that forthwith because it contained an omission, and I set corrected. Okay. Probability is currently 1. That's true. But at least I can vary it by it's meant functionally, it's meant to dictate the probability. And if I added other scenarios, sometimes they'll go to the community and sometimes they won't. 0 probability chance they'll start to be synchronized again, because they'll all be in a 24-hour cycle. So what we're trying to capture by this sort of 16 hours is really we're trying to capture the people that leave at a certain time of day. And while things were all balanced and we knew where people were going, it all made sense. But now we're leaving at the wrong time of day. So I'm going to stop this recording.